Welcome one and all to the mini lesson on inverse functions, where you will learn to identify the angles of a triangle, primarily a right triangle, by applying the inverse trig functions. So let's do a quick recap. Won't spend too much time. Pythagorean theorem, two sides of a right triangle, you can find the third. Given a coordinate graph, you can put it in terms of x, y, and r, where r is the hypotenuse, x, y are the two other sides, vertical and horizontal. Here are the three trig functions, sine, cosine, tangent, where you have it in terms of both the x, y, r coordinate points, and you could also have it in non-coordinate graph, where it's opposite, adjacent, and the hypotenuse. Here are the cosecant, secant, cotangent. Again, that's the same thing, just remember they're all flipped. And here's all of them put together, primarily in the x, y, r form. We also quickly want to recap on reciprocal identities, where each pair are reciprocals of each other, where it's just fraction flip. So sine theta is the same as 1 over cosecant theta, and so on and so forth. Here's our primary lesson right here, the inverse trig functions. Don't confuse it with reciprocal identities where you flip the fraction. What the primary goal of this is to find the missing angle. So inverse trig functions are the opposites of trig functions, same as how adding is the opposite of subtracting, and dividing is the opposite of multiplying. So the only way to find the actual angle itself and get it by itself in an equation is you would find the inverse sign, and this is where you would put the trig value. So in this situation, y over r. You see how the sign has the power of -1? That's how you can tell that's an inverse trig function. Now don't apply the exponent rule here. This is where it's like the only exception to that. Okay, don't change it to 1 over sine. That's not how it works. It is the symbol for it. You can also be given in this form where you see the words arc sine. Arc sine is the same as inverse sine. And that's how you find the angle, both degrees or radian form. So sine, inverse sine, arc sine. Again, remember how they associate with the ratio itself given inside that inverse trig function, and that's how you get the angle by itself. So to go to example, here's an example, a previous example where you find a coordinate point where you would only see this, and you say, all right, let's draw it on the graph if they gave me a point. So 3, 4 gives me this right triangle where I have the two sides, and if I wanted to find the r, I would have to apply the Pythagorean theorem. So that's how I know r is equal to 5. And then you would set up all your trig ratios. So each and every single one of these trig functions have a different ratio, okay? Because they require different parts of the triangle to form the fraction. And then you leave it at that. However, if I were to now ask you for that specific angle that we were dealing with, the angle from the center of the triangle, from the origin, then now you can apply the inverse function, where you would place each trig ratio inside with its corresponding inverse trig function. So inverse sine has 4 over 5, inverse cosine has 3 over 5. Here's the thing though, because we're finding the one angle, it doesn't matter which trig function you pick, because if you do it correctly, they should all end up being the same angle, because we're trying to find that one specific angle. And then once you find that angle, you can go ahead and find the third angle, because you already know that one of the angles is a 90 degree, because it's a right triangle. So now how do you actually do that? Well, on a Desmos graphing calculator, it's really straightforward. Because what you do is you go to the keypad, you click on the functions, and it has all 6 inverse trig functions, which is really, really, really nice. So let's just say we want to find what the inverse of tangent was. So you go to inverse of tangent, and you type in, hey, the ratio in that one was 4 over 3. So I'm going to type in 4 over 3. And guess what? I got 53.13010235542. And there you go. I am done. That's all you have to do to find the inverse, to apply the inverse function to find the missing angle. And you could choose whichever trig function you like. It still gives you the same exact angle. Now the only thing you have to be careful of is that you make sure that it's in degrees mode. So change the settings to degrees mode. Okay. So primarily use Desmos because it has all 6 inverse trig functions. If you were to use a graphing calculator, you would only have these 3. So use Desmos to save yourself some trouble in finding the inverse trig functions itself. So if I were to go over here and apply it in radians, if I want to find the angle in radians, well, I go back to Desmos, I change the settings to radians, and guess what? Desmos even changes it automatically for me to radians form because I already have it typed in correctly. So as long as you have the correct ratio, or whatever the value may be, it may not be a fraction, it may be like, I don't know, decimal form, 0.8, da 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 da. You still put it in there, and that's how you find the angle in degrees or radians. And that's that. In a separate video, we'll go into more detail about how you can take inverse trig functions into a more difficult region, but that's your main introduction to this lesson.